Hi, nice to see you again. Talk about the universe. Have you ever wondered what the largest planet is? The biggest star? The biggest black hole? Or a lot of other things in the universe? In this video series, Mr. Tan will go through the quality with you, the best of the universe. Welcome to Brain-Shattering Facts Part 10. Absolute heat. While the average surface temperature, the Earth is about 14 degrees Celsius. The boiling temperature of water at sea level is 100 degrees Celsius. The melting temperature of lead is 327.5 degrees Celsius. Gold is 1064 degrees. Of iron is 1.538 degrees. Of tungsten or tungsten. Raw materials have the highest melting point ever known. It's 3422 degrees Celsius. A little higher, we have the surface temperature of the sun at about 5505 degrees Celsius, or the temperature in the Earth's core. It's about 6000 degrees Celsius. Even more formidable, we have the temperature at the core of the sun, where nuclear fusion reactions occur, extremely intense, at about 15 million degrees Celsius. Or some documents say, the temperature produced by hydrogen bomb explosions, in theory, the emphasis is on theory, can reach 100 million degrees Celsius, enough to evaporate immediately any material you can think of. Whether it's mascots, like the African grassland elephant, and talk about here, you're more likely to ask, so what's more likely to get hotter than 100 million degrees Celsius? That's right, friend. By using the Large Hadron Collider, the scientists gave the lead ions a bump, at speeds approaching the speed of light. The collision broke down neutrons and protons into smaller particles, our quarks and gluons. At the same time producing, the temperature is about 5.5 trillion degrees Celsius. That's about 366,666 times more the temperature at the core of the sun. In a moment, and that's still not the maximum temperature limit. In nature, let me introduce you to the Planck temperature concept. Planck temperature. It's also called absolute heat, the highest theoretical temperature. It can be achieved in space. According to that, absolute heat is exactly equal to 1.417 by 10 to the power of 32 degrees Celsius. Beyond this limit, the energy of the particles in the universe would be so great, the gravitational force between them, it's become too strong and it's no longer gravity. That's the only moment that absolute heat is thought to be almost universal, that after about 10,000 seconds since the Big Bang, the opposite of absolute closure is absolute zero, has a value of minus 273.15 degrees Celsius, is the lowest possible temperature limit? In theory, at absolute zero, every particle, every atom, and every matter comes to a stop. Listen, maybe you figured it out. The blackest object in the universe is a black hole. Why is a black hole the blackest? Then please listen again. That's how they define a black hole. It's called a hole, but it's not a hole. It's a region in spacetime, has such strong gravity that it's blocking everything, including particles and electronic radiation such as light, coming out from within it. It's because light can't escape from the inside. A black hole, they become the ultimate black object, has a deep and pure blackness. In terms of nature, a black hole is one of the stellar remnants or remnants, in addition to some other types of star remnants that you've probably heard of somewhere, like white dwarfs or neutrons. They're the endpoints, or the final shape of a star, in a process that they call stellar evolution. According to that, the little stars, with 110 times the mass of the sun, will evolve into white dwarfs. The larger stars, with 1029 times the mass of the sun, will evolve into neutron stars. Only the largest and heaviest stars, with folding volume, from 29 times the mass of the sun or more, the honor of being evolved into. It's the most beautiful thing in the universe called a black hole. Talk about the black. The source of the black hole has a power source that can hold even light of the universe. Comes from a concept called gravitational singularity, a spacetime singularity, or simply a singularity. That's why they call the singularity by a very peculiar name, Not because it's weird. It's most likely because people don't understand, or not being able to fully understand its nature. Accordingly, people describe the singularity is at the center of a black hole, is a region or a point at which the curvature of spacetime reaches infinity, or easier to understand, it's thought that the singularity is where all of the star's material remains, compressed to an infinite density, at an infinitely small point that generates an infinitely large amount of gravity. Speaking of which, we know another record for black holes, that their objects has the greatest density in the universe. Let's go to some records of the size of black holes. Although it's true in theory, a black hole can be made of any object, have mass and can be arbitrarily small, as long as you get a super compressed material software capable of compressing objects of any mass back to the Schwarzschild radius, a concept that simply means if the radius of the object less than this value, it's going to become a black hole. To make it easy for you to imagine, if you put the Earth in a black hole compressor, we'll get a black hole with a radius of just 9 millimeters. However, with the power of WinRAR and existing file stroke software, the day you can produce black holes, it seems it's far away. Back to reality. We have the record for the smallest black hole in the universe, XTE J1650-500, with published volumes. By the time they found it in 2008, about 3.8 times the mass of the Sun, and it's only about 24 kilometers in diameter. In the opposite direction, the largest black hole ever discovered. It's 66 billion times the mass of the Sun. It's about 10 billion 400 million light-years from Earth, in a superquasar called TON 618. Skip-Talkian, a kind of fictional nut. It is said, always moving faster than the speed of light. Then light is the fastest moving thing in the universe, with velocity in a vacuum, at about 299,792,458 meters per second. It should also be noted that light is essentially electronic radiation. It's made up of photons, a fundamental particle with no mass. According to Albert Einstein's special theory of relativity, only particles with no mass that can travel at the speed of light. And as long as this theory is accurate, there won't be any material can reach the speed of light, simply because they define matter, are substances that have mass and volume. And the fastest matter in the universe ever recorded are superheated plasma masses, with approximately the same mass. The mass of Jupiter, shot out from the cores of galaxies, extremely active, still commonly known as blazars, a kind of quasar. According to that, people have observed giant plasma masses in the form of water droplets coming out of the blazars at about 299,762 kilometers per second. That's approximately 99.99% of the speed of light. This shows that the activity at the core of these galaxies is extremely intense, with the ability to generate energy that can't be visualized by the human brain. To make it easy for you to imagine, just by putting a bowling ball reaching the same speed as above, we need to come all the energy that's generated on Earth within a week. Talk about speed, though. The universe at the present time is constantly expanding at a speed greater than the speed of light. That's why the observable part of the universe, more precisely, is the computable part of the universe, up to 93 billion light-years in diameter. The age of the universe is only 13.799 billion years. But this is not a violation. Special theory of relativity, because of this theory, only applies to objects that are inside the universe. It doesn't apply to the universe itself, and so the universe expanding faster than the speed of light, according to preference. A star anywhere in the universe, it's always the center of attention. According to Wikipedia, a star is defined as an astronomical object, consists of a glowing plasma sphere, and compressed into a mass, thanks to its own gravity, with the nearest star to us, the Sun, out of about to by 10 to the power of 23 stars that we've talked about in previous space videos. The largest star in terms of diameter has a name, UY Scuti or BD12 5055. It's about 5,100 light-years away, with approximately folded diameter 1.708 times the diameter of the Sun. That's about 2,374 million kilometers, but it's only 7 to 10 times heavier than the Sun. In terms of volume alone, the heaviest star ever known is called R136A1. It's 163,000 light-years away. It's about 315 times the mass of the Sun. That's about 626.2 by 10 to the power of 27 tons. But the diameter is just folding. 28.8 to 35.4 times the Sun. This is also, at the same time, the brightest star ever found, with a luminosity of about 8,710,000 times that of the Sun. With a solar brightness, it's a source of energy, are released as photons, is equal to 3.8 to 8 by 10 to the power of 26 W. In the opposite direction, the smallest star ever discovered with a name, EBLMJ055557 It's about 640 light-years away, only the diameter, and it's about 8% the mass of the Sun, and even slightly smaller than Jupiter, the largest planet in our solar system. Hello! It's good to see you again. In the next part of the space video. In the previous section, we already know the highest theoretical temperature can be achieved in space, the darkest and densest objects in the universe, the fastest thing in the universe, or some of the best things about the stars. In this next section, Mr. 10 Fact will take you through the records. It's even more interesting. Welcome to Brain-Shattering Facts Part 11. The brightest object in the universe. As I said in previous videos, there are three main conditions that cosmic entities, or the celestial, need. If you want to be recognized as a planet, that there's an orbit around a star, has enough mass to be able to bend itself into a circular mass, or nearly round, and have to clean up our orbit in space, or to put it simply, a planet, must become the absolute dominant entity in his fascinating school, through work or swallowing, or shoot up any big object around. That means that with the exception of natural satellites, there's no object is relatively large in size, allowed to exist in space. It's called the orbital region of a planet. In terms of size, they've divided the planets into two main groups. That's the terrestrial planet, or rocky planets, with the main component are rocks and metals. It also has a solid surface. This is a small group of planets, with the four representatives in the solar system being Mercury, Venus, Earth, and Mars, and the largest rocky planet ever discovered. It's called BD+2059 for B. It's only about 28,414 kilometers in diameter. That's about 2.3 times the diameter of the Earth. It's about 16.3 times the mass of the Earth, about 97,343 by 10 to the power of 18 tons. The other group is called the giant planets, including to smaller arms the gas giants, with hydrogen and helium as the main ingredients. The same to representatives in the solar system. It's Jupiter and Saturn. The other group of giant ice planets. It's made mostly of heavier volatile substances. It's oxygen, carbon, nitrogen, and sulfur. Of the two giant planets mentioned above, it's easy to see that the gas giants are the larger planets, with the largest representation in the solar system being Jupiter. Has an average diameter of up to 139,820 kilometers. It's about 11 times the diameter of the Earth. About the same volume, 1.989 by 10 power 27 tons. That's about 1 per 1047 the mass of the Sun, 317.8 times the mass of the Earth, and about 2.5 times the mass of the other 7 planets in the solar system combined. Back to the main content. We have the record for the largest gas giant planet. It's the largest planet ever discovered. GQ-LUPB with current diameter, about 3 times the diameter of Jupiter. That's about 419,466 kilometers. It's almost 33 times the diameter of the Earth, and about a third the diameter of the Sun. As you can see, GQ-LUPB is so large. It's about the same size, and even slightly larger than the size of countless stars. Because if you remember, the smallest star ever found appeared in the previous section, EBLMJ055557 only the diameter, equal to 0.8 times the diameter of the crystal. That's less than a third of the diameter. GQ loopy B. Single point makes EBLMJ055557 off. It's called a star. GQ loopy B must be a planet. Is in their mass. The smallest star in the universe, still 85.2 times the mass of Jupiter. While the largest planet, it's only 136 times heavier than Jupiter. That's why the gas giants, sometimes called the failed stars, as they carry the necessary materials of a star, but not heavy enough for nuclear fusion reactions, can start from the core. What that means is, if you're able to pump a huge amount of it continuously, hydrogen and helium into Jupiter, then surely at some point, our solar system will have to stars. Talk about heavy, the heaviest gas giant planet. It's also the heaviest planet ever known. It's called HR 2560 to b, with a diameter just a little bit larger than that of wood crystal, but it's 15 to 45 times the mass of this planet. In the opposite direction, we have a record, the lightest planet in the universe ever confirmed, Kepler 37b, orbiting the star Kepler 37, in the constellation Lyra. It's 2,300 light-years from Earth. It weighs just 59.72 times 10 to the power of 18 tons, or 12 by 10 to the power of 18 adult African elephants. That's 81% of the Moon's mass, or 10% of the Earth's mass. We also have the record for the hottest planet in the universe, belongs to Kepler 70b, with an estimated surface temperature of about 7,000 degrees Celsius. That's about 6,726 degrees Celsius, hotter than the surface temperature of the Sun, about 5,505 degrees Celsius, or the oldest planet in the universe. PSRB 162026b has been around for 12.7 billion years. That's 2.76 times older than the Sun, and is only about as young as the universe itself, 1.1 billion years. One of the ways we measure brightness of a star, a galaxy, or any other light source in the universe, it's comparing the energy coming out of the star, that galaxy or object, with the unit of solar luminosity. With a solar brightness, is the energy that's released in the form of photons is equal to 3.8 to 8 by 10 to the power of 26 W. In the previous part, we know that our 136A1, one of the brightest stars ever known, it's about 8,710,000 times the luminosity of the Sun. But our 136A1, still away from being the brightest object in the universe, a very far distance. Accordingly, we have supernova events. It's defined as events that happen all of a sudden, flashing and intense, at a time when stars are massive, to evolve into a new star, or a black hole, or when two stars collide and give birth to a new star, which included a big explosion, blowing a tremendous amount, matter of one or more stars, into outer space, at about 30,000 kilometers per second, or 10% of the speed of light. A supernova explosion can reach folding medium brightness, 5 to 10 billion times the brightness of the Sun. Besides that, we also have the brightest supernova ever recorded, with the designation ASASS and 15LH, discovered in the 14th of June 2015, with about 570 billion times the brightness of the Sun, and about 20 times the brightness of the entire Milky Way.
Wow!
No, this part is not wow. Next, we have quasars, roughly translated as a star-like object, is defined as a galactic nucleus. Ultra-bright operation, including a supermassive black hole at the center, and surrounded by a giant accretion disk of gas. So we have the average brightness of a quasar. It's about 1 trillion times the brightness of the Sun. With ton 618, the superquasar contains the heaviest supermassive black hole in the universe. Appeared in the previous section, it's also one of those, the brightest quasar, in the observable part of the universe, when it's about 140 trillion times brighter than the Sun, and completely overshadow the super-galaxy that contains it.
Wow!
No, this part is not wow. Be a little more bold. We have a galaxy. WISE J22 for 607.5705 to 6350, or W22 for 605 to 6. 12.5 billion light-years away. A galaxy belonging to a group of galaxies. It's called the extremely luminous infrared galaxy. So let's talk about super bright infrared galaxies, with a minimum brightness of 100 billion times that of the Sun. Accordingly, W2246056 seems to be the brightest galaxy in the universe at the present time, with 350 trillion times the brightness, solar brightness, while also producing energy. It's about 10,000 times larger than the Milky Way.
Wow.
Not yet. In fact, the brightest galaxy in the universe. It's not the brightest thing in the universe. If you remember, we've mentioned the blazar concept, which is essentially a quasar. But there's one of 10 energy flows straight towards the Earth. Make blazar basically always brighter than a regular blazar. Accordingly, we have the brightest blazar ever recorded. It's also the most distant astronomical object. Can be observed with binoculars. It's called CTA-102. It's 8 billion light-years from Earth, with the greatest brightness ever achieved, ranging from 500 trillion to 1 trillion. Solar brightness.
Wow.
Can you just shut up? And finally, the brightest thing the universe has ever known to man. It's not really a thing. It's a gamma ray burst with GRB designation 080319b. For those of you who don't know, gamma rays or gamma radiation, it's what made Bruce Banner transform into a Hulk. It's also the most powerful light, with the ability to pierce the scariest thing in the universe, in addition to some of the weaker light or radiation common in everyday life, like a ray of light, infrared rays, ultraviolet rays, or X-rays. Back to the main content. Image of the explosion gamma ray GRBO 80319b happened 7.5 billion years ago. Recorded on Earth at 6:12 International Time, the 19th of March 2008, and reached peak brightness, up to 3 million billion times the brightness of the Sun. And obviously, the human mind was never born for such cosmological estimates. So it's easy to imagine the brightest explosion, the brightest thing in the universe. So bright that in theory, you can actually see it with the naked eye at a distance of 7.5 billion light years. That's about 70,958 by 10 to the power of 18 kilometers. See, now go ahead and say wow.
Wow.
Hello! It's great to see you again in the next section, a video about the universe. Black holes are one of the astronomical objects, the most mysterious of the universe. So mysterious that until the 4th of October 2019, people haven't taken any pictures about a black hole in real life, which means that all the images, the videos that Mr. Tin Fact gave you in previous videos, it is 100% fake. But more importantly, this information also means that in the 4th of October 2019, people have taken pictures, the first image of a cosmic black hole. Not only that, it's also a supermassive black hole, with masses that are the order of magnitude in the universe. In this video, we're going to dissect this great event together. Welcome to Brain-Shattering Facts Part 12. The first black hole photo. Before getting to the main content, let's go back a little bit to the definition. Black holes, as we've mentioned many times, is a region in spacetime, has such strong gravity that it's blocking everything, including the light that comes from within it. A black hole is usually very massive, from a few times to a few dozen times the mass of the Sun. For black holes, formed from the collapse of massive stars by hundreds of thousands, millions, or even billions of times the mass of the Sun, and they're called supermassive black holes, whose origins are still a mystery. It's usually found in the center of most galaxies that are elliptical, or the spiral in the universe. According to that, we have a supermassive black hole at the center of the Milky Way, our home galaxy. It's a spiral galaxy called Sagittarius A. It's about 4 million times the mass of the Sun. Speaking of volume, it's called the heaviest black hole known in the universe. It's a supermassive black hole in ton 618, with 66 billion times the mass of the Sun that we showed in the previous video, seems to be under intense threat. When there's some information from the SDSS survey about a supermassive black hole, it's 196 billion times the mass of the Sun, with a name SDSSJ 1408 to 1.67 plus 0 to 5733.2. However, since no reliable source has been found to verify the above information, we're going to temporarily let ton 618 let the rain keep the wine for a while. Back to the main content. Even though the idea of an object is so heavy, light can't get out of it. It's been proposed since 1784 by the British scientist John Michell and was reinforced by the birth of relativity in the early 20th century. But to this day, there's still a lot of skepticism about the existence of black holes, simply because we've never captured any picture of a black hole. However, everything has changed since the image of the supermassive black hole M87 is at the center of an elliptical supergalaxy in the constellation Virgo with the name Messier 87, taken in 2017.
This is the nucleus of the galaxy M87, and this is the first ever image of a black hole.
It's the motherfucking Eagle Double G.
Snoop Dogg!
And here, you're living in a moment of history when you see the picture of a black hole in real life. However, it may be contrary to thought. The imagination of many, as well as images, the fake good simulation videos that you've seen over the years. The first supermassive black hole to be photographed. He doesn't look very photogenic. Or maybe this is a bad picture, where everything seems kind of foggy and magical. This is explained by M87 supermassive black hole is too small. With volume, it's about 6.5 billion times the mass of the Sun. The same diameter of the event horizon, boundary around a black hole that since then, everything including light. Once you're in, you can't go back out. It's only 40 billion kilometers. That's about 267 times as much the distance from the Earth to the Sun, or from the Sun to the Earth. That's why we call these horrible numbers small, because of the distance from the camera. The Earth to the person photographed is the supermassive black hole M87. Is so large, up to 53.5 million light years, or 5 by 10 to the power of 20 kilometers. That's about 12.5 billion times more, the size of the supermassive black hole.
We are looking into space, towards a galaxy, a giant galaxy, 500 billion light years away from us. Sorry, 500 billion kilometers away from us.
And to capture an image of such a small object, at such a great distance, we need a space super telescope, given the size of the planet. And while we obviously don't, or rather it can't be created, it's such an absurd big thing. Scientists can actually create something hundreds of thousands of times smaller, with the same power. That's the Event Horizon Telescope project, a network of 8 radio telescopes, 10,000 kilometers away from each other, but coordinated to observe M87 at the same time and simulate a super telescope about the size of the Earth. Back to the historic picture. We can easily see that. Bright circles, it's like a ring of fire, or the Eye of Sauron, the Dark Lord in the Lord of the Rings series. Out with the picture is a superheated gaseous accretion disk, with temperatures reaching billions of degrees Celsius and moving at speeds approaching the speed of light around the supermassive black hole. They act like a rice cooker, fattening for supermassive black holes. In the center of the picture, with spoons of space dust, and when the gas is hot, the boundary between the two light and dark is the event horizon. Boundary 1 goes no return, which we mentioned above. Please tell me a little more. The lighter part of the accretion disk, to show us the flow of matter, is constantly moving towards the Earth. And because they're moving at nearly the speed of light, they look brighter. The physical area on the opposite side, that's moving away from us. Scientists say based on the photo, they can confirm that these plasma streams are orbiting the supermassive black hole clockwise, and it took about 2 days so that these material flows can complete a loop around the supermassive black hole. Because it's a very active galactic nucleus, supermassive black hole M87, feeding material on the accretion plate at very high speed. This creates two streams of energy shot on both sides, at nearly the speed of light, is thought to span at least 5,000 light years, with one of them almost directly towards the Earth. What this means is, we took this picture of the supermassive black hole M87 in the direction perpendicular to this energy flow. That's why we're so lucky to capture both bright parts and the darkening of the accretion disk. One more thing, even though it's an accretion disk of space dust and gas, that's the superheated flow of matter around black holes, will move in a flat disk shape. But because the space-time around the black hole is bent to infinity, along with that, light will also bend when passing a black hole to form gravitational lenses, as I said in a video. So if you're able to fly close to the black hole M87 without losing his body, you can actually see the disk behind the black hole, and the scene at the time, it's likely to be something like this. Back to the main character, the first image of a real-life black hole. Maybe you don't realize, but through this image we know that humanity is actually one of the greatest creatures in the universe, where most of the images, videos that illustrate or simulate black holes, that we've seen on the internet, in documentary films, or on the Hollywood big screen, they're all quite similar, compared to an image of a black hole in real life. It can be said without exaggeration that the first true image of the black hole M87 was released. Not only does it make sense for YouTubers, help us in the mystery of ideas, there's something to make a video about, but also has a very important meaning for humanity's space exploration, when it's still evidence for the undeniable existence of black holes. And with that comes affirmation, confirmation of Einstein's greatness, along with the theory of relativity that he came up with more than a century ago. And before the end of the video, please provide one more information, incredibly brain boosting. That's the picture you've seen from the beginning of the video so far. It's not fake, of course, but it's already a super outdated image. When supermassive black hole M87 in this picture was the M87 supermassive black hole of more than 53.5 million years ago.